So it usually starts out with the best of intentions. You're working with a client, and they come back to you, and they say, okay, this design that you're working on is great. We're going to approve it. Let's go ahead. So you code it up, and they look at it, and they say, well, hold on. I know that we decided that this section would be black, but in certain cases, on certain pages, I want to see it blue instead. So now you've got an exception. So, okay, no problem. You just go that extra level deep, and you go back to the customer, and they say, okay, that's great, except I didn't really expect that the list in that section would also go blue. Can we get that back to going black? And you think, okay, well, let's go another level deep, no problem. And then they come back to you and say, hey, I've got a great idea. Instead of the entire list being black, let's have the first thing blue. So at this point, you're silently ripping out your hair, but you do it anyway, and you built this fairly lengthy chain of dependencies, and then they come back to you and say, hey, I've got another great idea. Let's go orange on mobile. And so you've got to take the entire selector block and copy and paste that in a media query, and then finally, you know, you're just about to launch the site, and you get that frantic last-minute phone call saying, hey, you know what? I changed my mind. I just want it to all be black. So does this sound familiar to you guys, this kind of like increasing complexity, this fighting with yourself and rules that you've written in the past? You know, maybe you didn't see it. Maybe some of these rules were spread out across multiple files. You weren't really aware that you were building this chain of dependency. But CSS is supposed to be simple, right? And then we tried building things like this. Sites that have to work on hundreds of different device classes, sites that have hundreds of kilobytes of code, potentially thousands of lines of CSS, sites where you're working with teams of other people, maybe dozens of other people, and you all have to understand the same code base. So maybe CSS is not as simple as they tell us it's supposed to be. I want to talk about how we make sense of all this. And I apologize, this is an extremely technical topic for 10 a.m., but bear with me because I got to present it, you got to listen to it, and we'll get through this together. So, a little something about me. This is where you can find me on Twitter. I work for a company called Mobify in Vancouver, so hi, fellow Canadian here in the audience. Speaking of Vancouver, if you guys are looking at our weather over this past winter with like seething rage and jealousy, good news, we're hiring, so come talk to me after. So you probably, if you heard of me before, you probably heard of me because of the site that I built, the CSS Garden. This was a site that I built 12 years ago in a much simpler time, and I was reminded of just how much things have changed a couple of years back. On the 10-year anniversary of the site, I did a relaunch in HTML5 and CSS3, and there's been a bunch of new designs submitted that are much more modern. And as part of that relaunch, I created a brand new default design for the site. And I've got some memories of back in the day, 12 years ago, building that initial design, spending most of my time in Photoshop, and maybe just like a couple of evenings writing a couple lines of CSS to get the thing together before I launched it. This design was, responsive. It used a bunch of web fonts. It works across a bunch of different devices. It's a fairly complicated layout where I'm using a whole bunch of ideas that I wanted to test out. And it took me more like a month of evenings to put this thing together. So that was kind of a drastic difference between the experience of building both of those. So we design systems with CSS, but lately there's been a little bit more focus on how we actually design our CSS itself. I've been thinking about this a little bit over the last couple of years, and I like how we do it now at Mobify, so I wanted to share some of that with you guys. This talk is really about exposing complexity. A lot of the times, as you're fighting through those battles that I was kind of illustrating at the beginning, you don't really understand what the right way was to do it until you've gone through and done it the wrong way. It's really easy to see what the right way would have been on reflection. So I'm hoping that through this talk we can save a step. So let's start by talking about the problems that we needed to solve at Mobify. This is an important thing to clarify, I think. We are a product team, and I think that does force a certain amount of thinking. Some of you are probably coming from more of a services background, and I think that there's overlap, but I may be talking about something that's a little bit more product specific. So yeah, that's just my caveat. So years of CSS was built up in our system without any sort of structure. We were just kind of like chipping away at it, and we ended up with this gigantic bloated code base. Now, SASS was actually a bit of a problem. We used SASS for our pre-processing, and I'm not going to blame the tool. It wasn't the tool's fault. It was our fault for abusing SASS and using it wrong. There's tools out there like linters and other post-authoring tools that can help reduce the size of the code base, but that is really like a Band-Aid. It just fixes the surface wound. It doesn't do anything about that underlying fracture. So because of this code base, we noticed that there was a lot of friction when we were going in to develop new things. You have to stop and think, well, okay, I need to refamiliarize myself with what's going on over here. Can I actually change anything without breaking something unintentionally? And it was just really slowing us down. At the same time, we were bringing on more designers and front-end engineers. And it turns out that what's good for one person working in isolation doesn't necessarily make sense for a lot of different people. The whole late-night drunken coding thing, that doesn't scale. So what we wanted to do is blow away the old and design this brand new system that would be structured, it would be maintainable, and it wouldn't cause a massive refactor a couple of years later. So first of all, let's define our terms. What is a CSS methodology? It's essentially a naming system. It's a way of applying a specific syntax to your selectors and keeping that consistent. It really does come down to selectors and how you write those. There's a little bit about how you nest those. It's a little bit about the syntax that you're using as you're writing your CSS. And equally as important, it's sometimes about the syntax that you're not using. So we're obviously not the first people to think about this. There's a lot of really great solutions for this already. These all have slightly different syntax, slightly different concepts behind them. And hopefully you've heard of a couple of these because I think that I'm going to be taking a couple shortcuts that assume that you know what I'm talking about. So we did a little bit of research up front before committing, but we decided not to use any of the other ones. We liked them, but we didn't see that perfect fit for us. The BEM syntax was actually fairly close to what we wanted to do, but BEM is not just a CSS methodology. It's basically an entire front-end development framework, and we didn't really want all of that. We were just looking to solve our CSS problem at the time. So what about Bootstrap or Foundation? Well, we actually were using Bootstrap previously, and that was one of the reasons why we were in such a mess. We had chosen Bootstrap to get started quickly, and Bootstrap is fantastic for developing a rapid UI, but once you start customizing it and changing it over time and building custom components that live outside of what Bootstrap offers, that's when it starts breaking down a little bit. So what we found is over time, we were using a lot less of Bootstrap and a lot more of our custom things to the point where we just really weren't getting any benefit from it at all. So it was just needless bloat. For us, it just stopped being the right tool for the job. Also, those were frameworks. Bootstrap and Foundation are frameworks, and that's not the same thing as a methodology. A framework is more of a collection of pre-built things that you can use. You can just roll them out quickly, and they're going to be all of the components that you build your work off of. A methodology, on the other hand, it's more of a philosophy. It's a way of doing it yourself. And the outcome actually might look quite similar to a framework. You might get something similar to Bootstrap, but it's going to be a lot more custom for you and your product or your website or your app or whatever. So the last thing that the world needs is another one, but of course we built one anyway. Just like any good medium to large-sized company, wasn't invented here, not good enough. We evolved this house syntax, and we call it Argon. We use it every day. I really like it. Now, after this talk, should you go out and adopt it? No, I don't think so. I'm not here to sell you on some brand new thing. The point isn't really to convince you to use it. It's more of, I want to use what we did with Argon as a case study to talk about why we made decisions that we made, and how we went from no order to a very structured system. I don't want to tell you what to do. You're facing different problems, but hopefully you can learn a little bit from our experience. So, going into this exercise, what were our goals? How do we know at the end that we've done a good job? The main goal comes down to predictability, and I think all the other goals kind of stem off of this a little bit. Can I make sense of the code base at a glance? Do I know where to look when I need to go in and debug? Can I do that even if I haven't been in the system in 6 months? Another goal was keep our code dry. Dry stands for don't repeat yourself. This is a fairly fundamental software engineering principle, and I think what's good enough for our engineering team is probably good enough for our front-end team as well. So what I mean by not repeating ourselves is taking redundancy like this, where you're using the same rules over and over again with different selectors, and being a little bit more logical about grouping and making sure that every single rule, every single declaration has its own unique reason for being there. Major goal was actually reusability as well. Less code overall, but more intelligent reuse of the code that exists. So let's say that you're a new hire to the company and you've never seen the code base before and you're asked to go in and make a significant change. And then you see something like this. Do you think that this is something that you'd reuse? Do you think that you'd even slow down to figure out what this was doing before just writing your own thing? Probably not. Now, on the other hand, it's much easier to make sense of at a glance, and it might be something that you'd consider reusing elsewhere. Now, modularity, this is how we get our reusability, and I like to use a Lego analogy here. Maybe you guys got these little red bricks from Lighthouse Labs in your bags. Modular CSS is the equivalent of Lego to me. It's small pieces that we can rapidly throw together to build a bigger whole. If we're successful, what I liked about Bootstrap, that ability to rapidly build a UI, should work with our system as well. We should be able to actually do prototyping in the browser. We should be able to have a bunch of components and drop them into different contexts, and they should adapt to those different contexts. Now, a lofty goal was to not actually fight any more specificity battles, so we never want to do this again. And finally, we wanted to get everyone on the same page and make sure that we were all writing the same style of code. My goal here was that I should be able to look at any particular block of rules and not know if I wrote it or if somebody else wrote it. That allows you to think a lot less about syntax and focus more on what's important, the functionality. So, I mean, speaking of which, this was a system that I didn't develop myself. This was developed across a team. I had a couple of core collaborators as we were building it. And I thought that was actually pretty critical. Like, when you're building something that other people have to use, it's probably a good idea to include them in the conversation, not just so that they feel like, they had their voice heard, but also so that you've got multiple brains thinking about the problem, and you can have those debates on finer points of, like, is this a component or should it be something else? So we'll talk about selectors first to give you an idea of what we actually came up with. Here's what it looks like. This is Argon at a glance. You don't know what's going on here, but I do. I know immediately what each one of those pieces means. Now, these are super ugly selectors, and that's good. We want that. We don't care about the semantics in those classes because it's true that there are no machines out there that can take the semantics that you build and parse them and deliver real value to end users. So if that's the case, who are we building them for? Well, the browser to a certain degree, but developers. We're designing our classes for developers so developers can make sense of them. So let me talk through each one of the pieces of this. The contrast is holding up here. I gave this presentation once, so you couldn't see any of the gray text, so it made it a little hard. First of all is the namespace. Now, we thought at the time that it was actually really important to namespace every single product that we were throwing this code base at. This would make each particular selector distinct and make it very clear when we were combining the interfaces from multiple products together or whatever, where the style was coming from. In hindsight, I actually think that this is proving more of a burden than a benefit. What's happening is that the style is leaking between different products, and we're finding that we're applying a selector from a different product for the one that we're currently working on. So I don't think that we should have done it this way, and we probably would drop the namespace if we were to go back and redo it. And I think the most important thing that we learned here is that a really good naming system should have multiple sources of inputs, but they should all be able to coexist. You shouldn't have to worry about conflicts because you designed it carefully ahead of time. Okay, the next piece. This is the component, and this is kind of like our base piece. Everything within Argon starts with a component. Those components should stand alone, so you should be able to drop them anywhere in a page and they should just work, and they should render exactly like the style guide in that case. So for me, the components are like the 4x2 Lego bricks. They're the fundamental unit. They're the base pieces that we're going to snap together to build the projects. This is an example of a component that we built in Argon. It's fairly simple. It's a panel, it's got a heading, and it's got a paragraph. Now, it doesn't necessarily have to have either of those two. Those are descendants, and we'll talk about those in a sec. Modifiers. So modifiers are variations on the base component. They're taking the context of that component and changing it based on what the class is. So what we're doing with the modifiers, we're applying it directly to the same element that gets the component class in the first place. So that's a second class that's on that particular element. You'll note that we camel case at this point. That's because we've already reserved hyphens and underscores for other uses, and I will talk about those in a sec. So modifiers, they're kind of like the weird other bricks in Lego, the things that do like other jobs that the 4x2 bricks on their own can't. In Argon, this is what our modifiers get us. Variations, things like, confirmation dialogues. You're about to do something really stupid. Do you really want to do that? Dialogues. Things like that. And that's kind of our base panel with a couple of modifiers applied to it. And then we have our descendants. And descendants are like the subcomponents in our system. They're the granular pieces that make up a component. They're slightly independent of that component. The component doesn't necessarily need them, but the descendants themselves can't live outside of that component. They can't live without the context of that component. So they can't stand alone. There's not really a direct Lego analogy for this one, kind of broke down at this point, so I was like, well, maybe it could be like various configurations of that smaller, the 4x2 in smaller doses, but in reality, this is what our descendants look like. It's all of those pieces that go into the base component. There's no limit on how many we can have. We can have 0, we can have 100, but the key thing is that each one of those pieces belongs specifically to that parent component. So along with our classes and our syntax here, we have rules for how we're going to write CSS. We've got some best practices that we follow. If we have anything in the system that's styled, we style it with a class. There are no exceptions. This has some consequences. This means that we don't style IDs. There's actually a couple of reasons why this is good. One is that if we're building a modular system, having an ID of which you're only allowed to have a single one per page doesn't really work. You can't use multiples. So it doesn't make sense to use IDs for components. And the other problem with IDs is, of course, the specificity problem. If you guys have ever seen this chart before, it's increasing specificity from top to bottom. And by the time you hit ID, you're in that shark down in the lower right corner. So the shark eats everything above it. So it's a little bit of a battle to override that. So we simply take any instances of IDs and just replace them with classes. Easy as that. Now, this is controversial. We don't style HTML elements at all. And the reason that we don't do this is because modular code needs to be portable. And if you style HTML elements, you're relying on specific markup and potentially specific structure and specific ordering of that markup. This introduces a little bit of overhead, and a lot of the time it's a lot easier if we could just style the markup itself. But there's some benefits that we get from this. So what we do is we would take, let's say an H2, and we'd swap it out with a class that would be an equivalent of the styling rules. So what that does is it allows us to consider applying that particular rule to things that are not H2s. What if we could apply this to list items? What if we could apply it to H1s? It basically completely separates the semantics of what we're trying to build over on one hand with the presentation, which is really what CSS is about anyway. So that's the rule that we follow. Now, of course, there's always exceptions in every single system, so this is one that we made. We really, honestly, don't want to have to go in and style every single paragraph or apply classes to every single anchor. That would just be super painful. So we do have a very simple, just a couple HTML elements in a base style file that we apply to the site, and that's how we kind of get around the redundancy that otherwise would have caused. So it seemed like, there's a balance, and this was a pretty good place to break the rules. So, speaking of specificity, it's really easy to write big, long selectors that end up being super hard to override later on. So what we try to do is we limit those selectors to as few levels as possible. If you go over 3 selectors deep, you better have a really good reason. So something like this, not acceptable. This is what SASS can produce if you don't understand it. If you don't fundamentally get how SASS is rendering out the CSS, you tend to go overboard with your nesting, and you go many levels deep, and you inadvertently create this. So again, it's not the tool, it's how you use it, and you can avoid that if you're very careful about it. Just to give you an example of how bad this can get, this is something I found in the wild from a major Canadian company that some of you probably do business with, but I'm not going to name their names because they may be here in the audience. If you go to their site and view source, it's hundreds and hundreds and hundreds of selectors to basically set a single color. This is how out of control nesting and extends in SASS can get if you're doing it horribly wrong. I guess they're really serious about that gray. So we can do better. We make sure to outline what we expect from nesting, and if you can't do it right, then you're not allowed to do nesting in Argon. And of course, no use of the important keyword, because that is a specificity time bomb. It is the worst thing to have to override. So you're never allowed to use it, period. So I mentioned that we liked BEM earlier. One of our goals was to actually take those multiple classes and flatten them down so it would be the equivalent of a single BEM class. So if you've never seen it before, this is what BEM looks like. There's no namespace. Otherwise, Argon is quite similar. We are essentially taking those double underscores and double hyphens and converting them to classes and spaces where we need to. So BEM, Argon, very similar. We originally wanted actually quite a bit closer, so we tried the double underscore and double hyphen thing. It turns out this is invalid CSS. We had no idea at the time, but it kind of makes sense when you think about it. Like, remember before Grunt was a thing and you were writing all those WebKit prefixes by hand and you were using the double hyphen syntax? Yeah, there's a conflict there, so that's why they're reserved. But the single underscore and the single hyphen, on the other hand, are totally cool. Turns out they work everywhere except for Internet Explorer 6. Which we don't really care about, so perfect, that works great. So why did we do it this way? Essentially it comes down to we didn't want to write too much code, we wanted to make sure our code was nice and dry, and we didn't really want to give up SASS nesting. We still feel like SASS nesting has some value to it. So this is what Argon might look like when you're actually viewing the CSS, and this is what the equivalent in BEM might be. Now, you might feel like this is a bit of a preference thing, and you might be right, but where I think it really becomes clear why we did what we did is when we look at the HTML side of things. This is Argon, and this is BEM. So there's a lot of redundancy here. You're repeating the same selector the same class over and over and over again. So we decided that this approach worked better for us, so that's how we did it. Now, there's a couple of places where we break from these conventions. We really couldn't create a perfect, internally consistent system. A good example of this is where JavaScript and CSS overlap. Behavior and appearance are often quite connected, and that makes the naming a little bit fuzzy sometimes. So what we wanted to do was clearly define where the CSS ends and the JavaScript begins. So we created a couple of different ideas. One is a JavaScript-only control class. That JS prefix purposely breaks from the Argon syntax, and that is a sign to our designers that they're not allowed to touch that selector. You're not allowed to apply any style to it at all, period. This is essentially giving us a way of making a promise to our development team that we're not going to break things through our style. And if you think about, like, you know, some of the things that you could potentially break, you've got display properties. You know, if you actually display none something that the developer was relying on to be on the page, that can cause some big issues. Now, we couldn't erase all of that JavaScript CSS overlap. When we're toggling states, it turns out that you do need both style and some JavaScript control over it. So we've created a second type of class, these state classes. They're very simple. We don't apply style rules beyond simply display and animation properties and I think position the odd time. They're purposely quite light, and you wouldn't apply your main style and your fonts and your borders to these particular ones. This is really just about controlling those states. So Argon's a lot bigger than we actually have time for today. We did a lot of really crazy stuff with generated colors and grids in SASS, and I'm not going to talk about that, but I will make sure these slides are available to you, and there's some other articles from other people who have written similar systems to this that you should definitely go and check out if you're interested in this topic. There's some alternative perspectives in here. I'm presenting one approach. Other people took very different approaches, and I think, yeah, you should probably do your research if this is something you expect to roll out. So speaking of rolling out, we built this new system. Now it's time to actually get it into production. How are we going to do that? Are we going to go in and refactor the entire application all at once and put development on hold for like a couple of weeks? Yeah, no, that would not go over too well. So we needed a strategy to do it. We decided to apply Argon to new features at first, or new work on older features. And the way that we did it is, let's say that this is the sitemap here. We would take one particular template from that sitemap, clone it, add a new URL, and then apply Argon to that and convert it over. Then we'd eventually flush it out with content, and it would become kind of a working copy. Now this is at a separate URL, and we'd launch this staff only so that we could test it and make sure that it works, and then eventually we'd launch it to the public and just swap that out with the old feature. Now, obviously this happened over time, so there's potential for things to shift a little bit. It's really hard to resist the temptation when you're refactoring something to go in there and not fix some of the design decisions that bug you. So that did happen a little bit, and the way that we coped with that is we created this idea of a tweak file. It was just like very light style rules to tweak the new stuff so it looked like the old stuff. Now, as we worked on this, we changed more sections, we converted more over. New features were built out on Argon from default. We had a couple more tweak files. Eventually, we hit critical mass. And at that point, the style tweaks could potentially go away, or we could just reverse them so that the tweaks are about applying the new style to the old and keeping them in line a little bit longer. Then one day we're done. For us, it took about a year to roll out Argon fully. It was a very gradual, methodical process. And something that this approach didn't factor in is like, what if you rebrand during that time, which is something that we did. You could do a bunch of extra work to fix it. You could go in and maintain two completely different sets of styles. But we decided that we really didn't want to update the branding of the product because I think, at this point we've seen this a lot. We've seen the convention where a site refreshes their marketing forward presence or whatever, but the product, on the other hand, is still the kind of same old, same old. Now, PayPal has actually since redesigned the product, so not a great example anymore, but this did exist for quite a few years. In a perfect world, we would do this all at once ourselves. But this approach, it allows us to keep moving forward by just not worrying about that kind of brand inconsistency for a little bit. We can keep moving forward and not be held back by the legacy. So, we've had Argon for about a year now. I mentioned some of our goals at the beginning. How did we do? Did it work out? I'd say it's been pretty good overall. We didn't get everything right, as we kind of saw in the name spacing, but it's worked out pretty well. The specificity battles are like super rare. We really don't have to think about that anymore. When we bring in new team members, they have to work with the system that we build. Actually, it's funny that, all this time later, the collaborators that I built the system with no longer work for the company. We've got an entirely different crew there who are working with it. And it's going well, actually. The caveat is that we do tend to hire designers who code, that kind of like unicorn, but I think a lot of you are probably exactly that. We're finding that the ramp-up problems are actually not in understanding the system in the first place. It comes from actually working with it and getting into the fine details about, design decisions, fundamental design decisions about why we built Argon and debating that. And that's great. We spent a bunch of time documenting this stuff. Not really the components, you can have generated style guides for that. More the theory, the concepts. Here's why you would use a component here, here's why you wouldn't. So provide lots of examples and counterexamples. That was really key, I think, for us to get new team members on board. Now, one of the things that I've noticed is that Argon does force us to think about it. And this is something I said was a problem with the old code base. But with Argon, I think it's a more valuable thought. You're not really trying to, refamiliarize yourself with the code base and make sense of this horrible mess. You're now thinking about complicated chains of descendants and modifiers and making sure that you're doing it right and that you're not using code that already exists elsewhere if you're writing something new. A big benefit has actually been from our code reviews. You've got this, all of a sudden you've got this instant understanding when you're reading somebody else's code. We don't really have any way of testing CSS the way that we do with JavaScript, but we do have eyeball tests. When you're doing that review, the bad syntax will just jump out at you immediately. And if everything looks right, you really don't have to think it through in any more depth. So this is great because it allows you to focus on what's important, and that's how the code is working and what it's accomplishing and if it meets the goals. It allows you to not think about the syntax nearly as much. Now, debugging, this can be super tricky. I haven't really talked about how we split up our files at all, but there were hundreds of files after the result of rolling out Argon. And it turns out it's not super obvious where exactly you go to look for a particular rule. SASS, of course, doesn't help that because SASS renders out one single CSS file, so it has no relation to the original. But this is something that was fixed about a year ago with SASS source maps. If you haven't seen these before, they essentially take the rendered CSS file and find out where exactly in the original SASS files that rule was coming from. And when you're inspecting in your browser inspector, it will tell you not only the file itself, but also the line number. So it's exactly like you would expect your inspector to work, only it also now works with SASS. This is a tricky thing to talk about because I think you need to be working with a system like this to kind of really wrap your head around it. But we have this very terse vocabulary with Argon. We really have just three fundamental units: components, modifiers, and descendants. That's not a lot of base units to work with. And the modifier is kind of tricky because that is really our main way of taking a component and changing it based on the context of that component. Turns out in a complicated system, you do that context shifting quite a bit. So we're finding that our modifiers are getting a little out of control now, where we see 3 or 4 different modifiers on a single element because it needs to work in 3 or 4 different contexts. So this might be something that we'd have to come back and rethink. I'm not sure that we got this part right. Now, file sizes. I did a bit of an audit before we started the process of creating Argon, and I went through the old code base. We were looking at about 250K of CSS alone, and that was just as a result of all this bloat and all this complexity. The good news is that after rolling out Argon, our file sizes were down to 250K. So exactly the same as before. Now, obviously, in both cases, we're gzipping and minifying and try to get those files much smaller for delivery. The difference here is that one of these is a system that we're comfortable maintaining. We don't have to be scared of going in and, changing something that inadvertently breaks something else, whereas the other was a huge mess. So it's 250K of more valuable CSS, so it's a trade-off, but I think it's worth it. Now, it's important to talk about this one because you might be thinking to yourself, well, I've got a lot of markup that I don't have control over, whether it's user-generated content or WYSIWYG editor, or you just have people working in your company who don't necessarily know how to write structured markup, which is pretty common. This approach doesn't really work. So in cases like that, you need to consider alternate strategies. Maybe you've got some sort of wrapper class and you isolate that user-generated content, and you've got styling just for that that's separate from the rest of the system. It doesn't mean that you can't use the system elsewhere on things you do have control over, but it does mean that there's a potential exception here that you have to account for. Now, this is something that actually worries me quite a bit. There's a cost to writing CSS this way. It is a lot of overhead, and right now we think it's worth it. But at some point, the benefits that we get from it may break down. What do we do at that point? Do we just declare bankruptcy and start over? Well, we already did that once. My theory on this, my best thinking right now, is a little bit ghost in the machine, but I feel like this is a common problem that the industry is having. I think we're building increasingly complex things, and a lot of people are having the same problems, which means that there's a lot of people thinking about it, and our tools are getting better and better and better. So I can't say what it looks like to write these complex systems in 3 or 4 years' time, but I'm absolutely convinced that the tools to maintain that and help us manage that complexity will be better at that point. Maybe not perfect, but that's the best I can do right now. I just feel this is a general industry problem, so we're going to work on this. All right, so finally, for us, the big breakthrough was really not about the syntax. Now, the syntax was a huge improvement over how we did it before. We now have a consistent naming structure and a convention that we follow. We didn't have that previously. But that's not the most important thing. For us, it was really about the discipline. It was about picking that one syntax and forcing ourselves to write it without making any compromises. that causes a lot of discussion, it causes some debate, you think things through a lot more with the rest of your team, and that's fantastic because that leads to higher quality code. Now, I mentioned this a little bit at the beginning. I don't think this approach is right for everything. You know, maybe you're developing sites for small businesses on a regular basis, you're cranking them out, and you're never coming back to them. This is probably not the best approach. If you've got a project where you need to maintain it over time, where you need to come back in and edit it in a couple months, a couple years, that's perfect. That's the kind of system that this works on. Anywhere where you're reusing code, anywhere where you're extending existing code, that's the sweet spot for CSS methodology. Now, what's better for your company goals? Having high quality code or shipping code often that fulfills the company's business goals? I think it's obviously the latter. And any system that you choose should favor shipping. The best architecture should assist the development process and speed it up. It shouldn't get in the way of it. I don't think that there's a universal perfect way of doing this. You know, our approach sure is not perfect. I can tell you a lot of other ways that I think we could have done things better. I've read through a lot of articles about how to construct these systems, though, and these are some of the articles that I linked earlier. Some of these are really good ideas. Some of them could potentially be untested. You know, I think it's really easy to hear a talk like this one or read some of those articles and think that's an interesting idea. That potentially solves a problem. Let's go out and do exactly what was suggested. But it's really important to find out how that worked for the person who proposed it. You know, it's a lot less easy to write that follow-up article a year later to talk about, you know, the things that you got right and the things that you got wrong. So if you're going to be doing something like this, make sure to look for that follow-up post and find out how that approach worked for that person and for their team. Because at the end of the day, it really is people who are consuming this. Computers don't write code yet. People do. When you have a choice, you should optimize for people. Thanks. So I believe we have plenty of time for questions. I can't see anybody, though. Can I get the house lights up? Thanks. Right there in the front. Okay, so the question was, how do you take an existing system and potentially downsize it? Well, I mean, there's two ways of approaching this. One, you take the stuff that's worked for you and improve it and strip away the bad code and slowly, you know, whittle it down to something that looks quite a bit more like what you expect to be building. The other approach is just to nuke it from orbit and start fresh. So the approach that I was recommending, how we did it, where it was just kind of a section at a time that we rolled out slowly, that was essentially us nuking it from orbit. We were moving away from what existed previously and creating a brand new code base. So that approach worked for us. I think it could potentially work for people who are just trying to improve an existing code base as well. You know, duplicate an existing page and apply your best thinking to that duplicate, test it out, have it live alongside the original for a while, and once you feel good about it, then you can actually say, okay, let's swap those two. This involves a little bit of redundancy. You know, you're going to create an entirely separate set of styles, and there's potentially a cost to the user for loading the CSS when they navigate from page to page. So that's unfortunately unavoidable unless you have the luxury of being able to do it all at once, which we absolutely didn't. Maybe you do. No problem. Anyone else? Darren. So the question was, how do we support, or how do we structure our components in the file system? What we do is we just give each component its own file. Where it gets really interesting is when you've got specific modifiers that, sorry, not modifiers, when you've got components within components. And you have to ask yourself where the class goes for that. You have a choice. Either it goes in the parent or it goes in the child. And the child component file could potentially reference the parent, or you could do it the other way around. What we decided to do was say that all of the context for how a component should be styled should live within that component's file. So our approach is to essentially say this component will be aware of its parents, and that means that the style, when it's in a specific parent, will be within that component's file itself. I hope I explained that well. It's a little bit of a confusing thing, and it would be far better if I had a code example to point you to right now. Any other questions? Over there. Okay, let me just see if I can repeat your question back to you. You asked if we have all these modifiers in our HTML, is that a bad thing? Ben and what I presented with Argon don't seem to solve that particular problem. You're polluting your HTML with modifiers? Is that what I heard you saying? I think we should have a conversation after. I'm not sure that I have anything immediately. Maybe I need to get into a little bit more depth with you. Other question? Yeah. With certain exceptions, we don't really care about selector performance. You know that if you follow Steve Souders, that's like one of the last things that you should be looking at to optimize, because the benefits that you're going to get are just so tiny and so incremental. There's a lot more important places you can be looking at optimizing performance. So for us, because we've got a fairly dedicated user base to the product that we're building this on, it's not a relevant thing. Were it a relevant thing, were we to dig into that, yes, I'm sure we would do some testing, but yeah, we have not done any performance testing on the components. One more question, right in the back there. My thoughts on JavaScript being used for CSS. Got it. Okay. So I think I presented something that is close to my opinion when I was talking about the intersection of behavior and appearance. When you look at those state classes that I was showing, is visible, is hidden, that's how we apply it. We try to make sure that the style itself is coming from CSS, and the JavaScript will just simply toggle when we decide to show that style. If you go to the next level, and you're perfectly allowed to do this with JavaScript, and actually start setting the style within it, for us, that is not the correct decision. Your mileage may vary. Cool. Thanks, everyone.